I've been wanting to do another talk on time for a while now, so in this talk I will go for the more basic principles of what we understand as time pertaining to perception and measurements, and then we will get slowly a little more abstract. Probably not in any specific order. I'm just going to talk about the different aspects as they come. We're going to start with a little bit of abstraction. For time to begin to exist at all, there has to be an observer and a larger observer, an environment. This already proves that time only exists as a relational necessity. For memory, for changes over time, and for attention purposes, there needs to be a relationship between an agent and the environment. This is a basic principle of time and computation and existence all the way down. And so if we assume that time at its first phases starts from infinity, which is paradoxical, but maybe not. It begins from infinity and infringes a limit upon itself. It could be anything from self-reflection. It could just be the nature of infinity. Infinity doesn't just mean infinity. It can mean many things, as we will find out. We could say that time either scales up or scales down through the agent and environment nested embedding. The truth is it's both. It scales up and it scales down. But there is one direction which has more significance than the other one. One cannot exist if the other one doesn't. And that is because the goals of an environment, for the agents to achieve the goals within that environment, the goals have to be top down, which means time in its pure state, in its nature, its own nature of itself, has to scale down. It's a top-down goal process. And so when we're talking of infinity, infinity has to have an agenda. First, for it to split off and limit itself, it needs an agenda to ask the question, to limit itself, experience from an observer. And if we choose to look at time through a computational lens, time is measured as the series of relational computations, as contained sections in an infinite, what we will call a hypergraph. If you want to know more about computational hypergraphs, you can look at the work of Stephen Wolfram and his model of the Roolead. And in simple physics terms, time is mass and spin and agential relationships, the relationships to the environment and the relationships with each other. Like our solar system, for example, the planets orbiting the sun. The sun is the ultimate goal. It gives out the ultimate goal, the threshold, the limits of time. And the planets dance within that time, creating their own personal time, pertaining to the sun's time in a relational way. Time only exists through relationships. And now we will look at what is known as in physics as the arrow of time, or arrows of time. How different concepts of time and different theories allow for different arrows. Let's take computational, for example. This is primarily a forward-based arrow, because what is known as computational irreducibility. It means that the computations that are done cannot be undone. They can't be reduced. They can't be reversed. There is only a forward computational evolution of things. The concepts in physics, apart from strong theories of negative time, I mean, they are strong in theory but not strong in observations. Physics also points to a progression-only arrow, so forward. Time is only a forward arrow. And then we run into what I refer to often as the mental layer, which also is known as things like the latent space, possibility space, or the platonic spaces. Here time naturally has more than one arrow, because memory is a requirement for growth and maintenance of attention. So here the arrow runs in a minimum of two directions. One backwards for memory, you access and have your attention on memory, and one forward for prediction, and one that's on the present, which is the progression of computation.
All your birds migrate from your mouth when you laugh, or when you find.
And so when we look at mental attributes such as memory and predictability, we can see that the mental aspects of our existence, of reality, allows us to use multiple arrows, sometimes simultaneously, able to predict the future and have our attention on the past. This is literally what creates our identity, with how we predict the future and how we choose to relate to the past versions of events that involved us, or things that we remember, events that we remember. So the arrow from the mental layer doesn't just pertain to computational irreducibility. It pertains to attention. And so if all things require the mental layer to exist, we have an embedded nesting of agent, environment, and each environment within itself is an agent. So it is agents all the way down, which means each one of these is an observer. Each one of these has the capacity for prediction, and it has the capacity for memory attention. So what we see here is that time is the attention of the observer and the attention of the environment. All scales create attention over time, meaning attention-based access to past and the future, predictability. This is how it reaches goals. The goals are on the higher environmental levels when concerning the agent. Through all these different concepts or perspectives on the same thing that we call time, one thing or two things seem prevalent throughout all of them. There are two main themes through time. One is relationships. Time cannot exist without the experience something has to experience the time, which means something has to create an environment to be experienced in. And secondly, there has to be attention, for memory's sake. This is why you can put your phone down on the table, go to the toilet, come back, and your phone is still there. The environment in which you live has the capacity to hold the memory of all the atoms and the atoms' formations and the whole room, so that nothing changes. Only the agents will change the environment. So memory is the agent's attention over time. Whether it's the environment's attention or the agent's attention, it doesn't matter, the principle stays the same. Memory is attention over time. Regardless of complexity or size, when concerning the mental layer, this is irrelevant. The limits of the environment, and each environment has different limits. So the limits of the environment allow for the capacity of the threshold of memory. Say gravity, for example, is a good indicator of the threshold of memory and the speed of light for this particular environment that we exist in, on this planet at this time. But by no means does that mean that this is universal. The infinite nature of existence at the top of the pyramid, from what everything came from, allows for many, many more possibilities. I wouldn't say infinite possibilities because there has to be an agenda, but I would say for infinite configurations of time and space. And all these concepts of time, they all point to non-Einstein versions of time, where Einstein would start off with time being something fundamental. And I'm not saying that time is not fully fundamental, but that the relationships that create time to be perceived seem to be fundamental, and that time is a gradient-dependent variable that is dictated by the gradients the relationships form with one another. Gravity is a perfect example. When we understand time and the gradient-dependent relationships, there is no such thing like what exists in physics as the three-body problem. When we understand that our physical reality, or what we perceive as a physical reality, is coupled with a mental layer and is the expression of mental attention, our understanding and our technology will advance so much. We will understand that we will approach things from the mental aspect, understanding that there is not just one direction, one evolution of time. And as a side note, just because computation appears to be a good reflection of universal evolution, that does not mean we can easily create minds by emulating physical computation, regardless of how complex and to the successful level of complexity we can emulate what we see physically. Computation is done in fields that nest through environment, agent processes to couple with or create a model that resonates to achieve goals. First, we have to understand the goals of minds and environments that embed from top down. Only then could we emulate something like a real growing mind that can self-replicate in physical reality. And to go a little more abstract, and maybe even radical. Because all things exist simultaneously, and with infinite possibilities and configurations, we run into what seems like a paradox. The computational irreducibility, meaning there is no undoing the computation, which I believe is true, yet also infinite possibilities. Otherwise there would be no limitations, there would be no scales, no time. Yet both these things exist, and both these things seem to have a conflict. How do we resolve the conflict? Well, the conflict resolves itself when we look at the idea of infinite possibility. That just because something descends through computation based on goals, from top-down goals, it does not mean that time only has one arrow, because the process of attention has memory, which technically means the past can still be affected through entanglement, and then the computation will be changed and continues. I think this is what people try to understand when they talk about something like the Mandela effect. Of course, the past can be changed when we look at how the mental layer approaches attention through memory, and that there must be infinite possibilities and configurations for things to exist at all. To go one step further, to understanding future potential technologies, as memory and prediction are mental attributes fueled by attention. The only way for physically constrained matter to move forward or backward in time, or from one space to another space, without motion through the space, to move backward or forward in time, would be to connect and access that time encased in a mental field, and the mass generated by the infinite possibilities. We are already witnessing this on the smallest scales in quantum entanglement. Experiments that show information being moved from one space to another, and now already mass included. Infinity must contain the energy that creates everything. We see this in glimpses when we look at the Higgs boson, which is a small little flicker of energy beyond the quarks. The nesting of fields or minds, it's the same thing, determine the configuration of atoms at submatter scales. Minds reduce infinity as goal boundaries. Only minds can travel the possibility space, and equally memory space. Wherever the attention can reach, the mind can go. And if minds are primary goal makers and configurators, then the mental layer is primary for matter. This should mean something for our technology and for our understanding, and generally how we will behave in reality itself. And now we'll have a look at the perception of time from the human perspective. And to understand perceptions of time, we have to look at the bandwidth of the present moment and scales of agent and environment and their own present moment. The fastest that we've found in experiments that we can actually experience the present moment through the body, through sensory input into the body, turns out to be around 1/5 of a second. so 20 milliseconds. These experiments are done by wearing headphones and having a click in the left ear and a click in the right ear, and then discerning which click came first. The quickest we can discern is about 1/5 of a second, and this is the closest we can get to the present moment through auditory stimulation. But this is only the speed of the body, the mind in the body. The mind itself is a lot more complex and a lot more fluid with time. This is why we have so many instances of precognition, the ability to perceive time before it happens. And just like I've mentioned before, the ability to predict into the future and have attention on memory. And so even in the click test, it is still the mind. It's the mind that operates through the interface of the brain and the body. It's just that when the body is stronger connected with the mind, when it's in an alert mode, high sensory input, this is when the mind is a little bit slower, a little bit more focused. Attention is a mental attribute. When the likeliness of the future is very strong and the mind can dissociate from the body slightly, say in dreams or through what people call visions and other forms of precognition, this is when we can have a sense of the future and then witness it happen before us. Because the predictability of that future was in the high potentials of happening. And the mind is not fastened to the present moment. The mind is fastened to where its attention goes. And so it is. Higher order thoughts, solutions, ideas are perceived when you alter or reduce sensory stimulation. So removing the mind from the noise of the body's environment, time from passing, so removing the mind away from the immediacy of the environment. Visual, touch and auditory stimuli mostly draw the mind tighter into the body. The mind then inhabits a subspace or subtime, not body dependent or body's environment dependent, but as alternative space and time, reaching more into what I refer to as the mental layer. And maybe some of these things seem like assumptions, but this is because I've already gone over all the groundwork in many previous videos. So for these things I'm saying here in this video about time to make more sense, you most likely will have to have understood the previous videos or concepts from similar people with similar concepts. And if you made it this far, thanks for listening.